Note that 7 problems are going to say show work. Make sure that you show work for those problems. On the test, you will have to submit a photo of your work through Schoology. The first question is evaluate the radical expression. When it's the square root squared, those cancel each other out. But when they cancel each other out, if you do the square, that makes a positive 25, and then the square root, it ends up being 5. So in your notes, it says that the square root of a negative number squared is the absolute value of that number. So the correct answer is 5. So in here, you'd want to type in 5. Write the rational exponent expression in radical form. Remember that the bottom of that fraction is the index of the radical and the top number is the exponent. So this is the 5th root of x raised to the 3rd. The computer will accept this answer. The computer will also accept this answer. I feel like the top answer is easier to type in. So to type this in, there's a square root button. There's also an nth root button. You want to click the nth root and then make the index 5, and then underneath the radical put the x and then raise it to the 3rd. And when you're done, it should look like what your paper looks like, kind of. Here's the first problem that asks you to show your work. So it wants you to use rational exponents to rewrite and simplify the expression. The 6th root of x to the 5th is the same as x to the 5/6. The 4th root of x is the same as x to the 1/4. With division, we subtract. So we subtract the exponents 5/6 minus 1/4. And I would just do this in your calculator. So 5 ABC button 6 minus 1 ABC button 4. It gives me the fraction 7/12. So x to the 7/12. Now, because the problem started in radical form, it needs to end in radical form. So you need to rewrite this as a radical. It's the 12th root of x to the 7th. So nth root, we have the 12th root of x raised to the 7th. Find the domain. When you have a cube root function, cube root functions have a domain of all real numbers. There are no restrictions to what can be in a cube root function. So if it's cube root, you click all real numbers. The next one is square root. In a square root function, if you've got square root of stuff, the stuff has to be greater than or equal to 0. So whatever's under the radical, 3x plus 12, put that greater than or equal to 0 and solve that inequality. So we subtract 12 on both sides. You can get 3x is greater than or equal to negative 12. Divide both sides by 3. X is greater than or equal to negative 4. So the correct domain is x is greater than or equal to negative 4. This is another one that asks you to show work. You've got the square root of 150, the square root of x to the 15th, the square root of y to the 3rd, and the square root of z to the 6th. For 150, you want to break this into a perfect square times another number. So we do 25 and 6. The square root of 25 is 5. So this term becomes 5 times the square root of 6. The square root of x to the 15th. How many groups of 2 are in 15? There are 7 groups of 2. That would be 14 of those x's. So the square root of x to the 14th is x to the 7th. There's still another square root of x. There's still an x left over. So 7 full groups of 2 with 1 left over. How many groups of 2 are in 3? There is 1 full group with 1 left over. How many groups of 2 are in 6? There are 3 full groups with none left over. When you write this as your final answer, you start with numbers not under the radical, and then letters not under the radical in alphabetical order, then one radical symbol, numbers, letters in alphabetical order. So when we type this in, we want to type in 5x to the 7th. Make sure you hit the right arrow to get out of your exponent. YZ raised to the 3rd, right arrow to get out of your exponent, and then a square root of 6xy. Here's another one that asks you to show your work. The square root of negative 20, we can simplify into the square root of negative 1, and then we take 20 and split 20 up into 4 and 5. 4 is a perfect square. That would be 2. The square root of negative 1 is I. So this is 2I square root of 5. It says plus the square root of negative 125. You've got that. I really should do a three-way. Negative 1, and then you want a perfect square times something else. We would do 25 times 5. Square root of 25 is 5. The square root of negative 1 is I, and we have that square root of 5. I square root of 5 is the same on both of these, so we can add the 2 and the 5 together to get 7I square root of 5. So 7, you will have to use the I on your keyboard because this math keyboard, oh, hey, it does have an I. Look at that. So 7I, and then we want the square root of 5. Another one asking you to show your work. When you have a radical on the bottom, you need to multiply the bottom and the top by the conjugate. So if it's 3 plus square root of 5, you'd multiply by 3 minus the square root of 5. On the top, you distribute. You've got 27 minus 9 times the square root of 5. On the bottom, we need to double distribute. 3 times 3 is 9. 3 times the negative square root of 5 is negative 3 square root of 5. Square root of 5 times 3 is 3 square root of 5. Square root of 5 times negative square root of 5. Positive times negative is negative, and the square root of 5 times the square root of 5 is simply 5. Those two middle terms are going to cancel each other out. So you've got 9 minus 5, which is 4, and 27 minus 9 square root of 5 on the top. To enter this in here, you're going to want to use your fraction button first, and then enter the top, 27 minus 9 square root of 5. On the bottom, 4. Again, show your work. You have the equation, the square root of x plus 17 plus 4 equals 9. You need to get the square root by itself. So subtract 4 on both sides. That will give us the square root of x plus 17 equals 5. Square both sides to get rid of the square root. X plus 17 equals 25. Subtract 17 on both sides to get x equals, checking my math here, 8. Now, it is a square root function, so I would take a moment to just make sure. Really what you're looking for is, if I put 8 in place of this x, am I going to create a situation where it's the square root of a negative number? 8 plus 17 is not going to be negative, so our answer of 8 is probably fine. But if you want to take the time to type this into your calculator and just make sure that it works, that certainly won't be wasted time. But because 8 plus 17 is not a negative number, you're probably fine. Again, show your work. The square root of x plus 6 equals x. Get the square root by itself, and then square both sides. Now this is where people usually go wrong. On the right side, x minus 6 squared means that you have to multiply x minus 6 times itself. When you multiply that out, you will get x squared minus 6x minus 6x, that's minus 12x, plus 36. Get 0 on one side. 0 equals x squared minus 13x plus 36. You are looking for two numbers that multiply to give you 36 and add up to negative 13. If you need to take a minute and write out all the ways to multiply to get 36, that's very helpful. It is negative 4 and negative 9. So our factored form is x minus 4, x minus 9, which means our solutions are 4 and 9. But you might notice that on this problem, there's only one place to enter an answer. So we need to make sure we check these. When you have two answers, definitely check them in the original problem. So we're checking them back in this original problem. So we have square root of 4 plus 6 needs to equal 4. Does 2 plus 6 equal 4? No, it does not. You probably now can just say 9 is your answer, but just to make sure that the answer isn't no solutions, square root of 9 plus 6 needs to equal 9. That checks out. So our answer is x equals 9. Write the expression as a complex number in standard form. We need to simplify the square root of negative 64. That is the square root of negative 1 times the square root of positive 64, which is 8 and I. So 23 minus 8i. 23 minus 8i. When you are subtracting with complex numbers, don't forget that you have to subtract the entire second complex number. So you've got 8 minus 8i minus a negative 1, which is plus 1, minus 3i. You have to distribute that negative. Then combine your like terms. 8 and 1 is 9, negative 8i and negative 3i is negative 11i. So our answer is 9 minus 11i. This one, it doesn't say show work, but you really should, because I don't know that anyone could do this correctly without showing work. You should show work on this problem. Negative 2 times 9 is negative 18. Positive 4i, 9i, and negative 2i squared. Anytime you have an I squared, that's a negative 1. So negative 2 times negative 1 is actually a positive 2. Negative 18 plus 2 is negative 16. 4i and 9i is 13i. So negative 16, that's not right, plus 13i. Okay, I am going to save question 14 and 15 for the second video. So if you need help with 14 and 15, make sure you watch the second video.